correct answer is that all swimming pool pump motors must be ground fault circuit interrupter protected, regardless of whether they are cord and plug connected or hardwired. This requirement is outlined in the National Electrical Code, NEC, section 680.21. B1, which states that fixed or portable swimming pool pumps shall be provided with a ground fault circuit interrupter protective device. The NEC is a nationally recognized electrical safety code that is used in the United States to ensure the safe installation and operation of electrical equipment. The NEC is updated every 3 years, with the most recent update being the 2020 edition, and then updated again every 3 years since. The reason why all swimming pool pump motors must be ground fault circuit interrupter protected is because they are considered to be a potential electrical hazard. Swimming pool water is a good conductor of electricity, and if a person comes into contact with a live electrical wire in the pool, they could be seriously injured or killed. Ground fault circuit interrupters help to prevent this by quickly tripping the circuit when they detect a fault, such as a wire that has become damaged or loose. It is important to note that ground fault circuit interrupters are only effective if they are properly installed and maintained. Ground fault circuit interrupters should be tested regularly to ensure that they are working properly. If a ground fault circuit interrupter does not trip when it should be replaced immediately. A ground fault circuit interrupter, or GFCI, is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing through a circuit. If it detects any imbalance, indicating that current is leaking to ground, it quickly cuts off the power. This happens much faster than a regular circuit breaker would trip, often in a fraction of a second, preventing serious injury or death. Ground fault circuit interrupters are particularly important in areas where water is present, such as bathrooms, kitchens, and, of course, swimming pools. The presence of water increases the risk of electrical shock, as water is a good conductor of electricity. There are several types of ground fault circuit interrupters. Firstly, there are receptacle ground fault circuit interrupters, which are installed as part of an electrical outlet. These are commonly found in bathrooms and kitchens. Secondly, there are circuit breaker ground fault circuit interrupters, which are installed in the electrical panel and protect an entire circuit. Thirdly, there are portable ground fault circuit interrupters, which can be plugged into an outlet and provide temporary ground fault protection. The NEC mandates ground fault circuit interrupter protection for various locations and equipment, with a particular emphasis on areas with increased electrical hazards. Some key examples include bathrooms, where all 125 volts, 15 amps and 20 amps receptacles must be ground fault circuit interrupter protected. Kitchens also require ground fault circuit interrupter protection for receptacles serving countertop surfaces. Outdoors, all 125 volts, 15 amps and 20 amps receptacles that are readily accessible must have ground fault circuit interrupter protection. In laundry areas, within 6 feet of the outside edge of a sink, ground fault circuit interrupter protection is required. Furthermore, all receptacles in unfinished basements and crawl spaces must be ground fault circuit interrupter protected. Swimming pools and spas have extensive ground fault circuit interrupter requirements covering pumps, lighting, and other electrical equipment. The purpose of ground fault circuit interrupter protection is to prevent electrical shock by detecting ground faults and interrupting the circuit quickly. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person touching a live wire. Ground fault circuit interrupters continuously monitor the current flowing in the hot and neutral wires of a circuit. If there is a difference of more than a few milliamperes between the current in these wires, it indicates that current is leaking to ground. When this happens, the ground fault circuit interrupter trips, cutting off the power to the circuit. The tripping time is typically very short, often less than 30 milliseconds, which is fast enough to prevent serious injury or death. Ground fault circuit interrupters should be tested regularly to ensure they are functioning correctly. The typical test involves pressing the test button on the ground fault circuit interrupter, which simulates a ground fault. If the ground fault circuit interrupter is working properly, it will trip and cut off power to the circuit. It is recommended to test ground fault circuit interrupters monthly. If a ground fault circuit interrupter fails to trip when tested, it should be replaced immediately. Common issues include nuisance tripping, which can be caused by faulty wiring or appliances, and complete failure, where the ground fault circuit interrupter no longer trips when tested or exposed to ground fault. To install a ground fault circuit interrupter receptacle, you will need a few tools including a screwdriver, wire strippers, and a voltage tester. Firstly, turn off the power to the circuit at the circuit breaker. Secondly, remove the existing receptacle from the electrical box. Thirdly, disconnect the wires from the old receptacle. Fourthly, connect the wires to the new ground fault circuit interrupter receptacle, matching the hot, neutral, and ground wires to the corresponding terminals. Fifthly, mount the ground fault circuit interrupter receptacle in the electrical box. Sixthly, turn the power back on at the circuit breaker and test the ground fault circuit interrupter receptacle. To install a ground fault circuit interrupter circuit breaker, you will need screwdrivers, wire strippers, a voltage tester, and safety glasses. Firstly, turn off the main power breaker in the electrical panel. Secondly, remove the panel cover and locate the circuit breaker for the circuit you want to protect. Thirdly, disconnect the wires from the old circuit breaker. Fourthly, connect the wires to the new ground fault circuit interrupter circuit breaker, matching the hot, neutral, and ground wires to the corresponding terminals. Fifthly, install the ground fault circuit interrupter circuit breaker in the electrical panel. Sixthly, turn the main power back on and test the ground fault circuit interrupter circuit breaker. Common mistakes to avoid include improper wiring, such as connecting the wires to the wrong terminals. Over-tightening the screws can damage the ground fault circuit interrupter. Failing to test the ground fault circuit interrupter after installation. Using ground fault circuit interrupters in circuits with known ground fault issues. Regular maintenance and testing are crucial for ground fault circuit interrupter devices. Ground fault circuit interrupters should be tested monthly to ensure they are functioning correctly. The test button on the ground fault circuit interrupter should be pressed to simulate a ground fault. If the ground fault circuit interrupter trips, it is working properly. If the ground fault circuit interrupter does not trip, it should be replaced immediately. Additionally, ground fault circuit interrupters should be visually inspected for any signs of damage or wear. If any issues are found, the ground fault circuit interrupter should be replaced. Swimming pool pump motors are required to have ground fault circuit interrupter protection regardless of whether they are cord and plug connected or hardwired. This requirement is specified in NEC section 680.21. D1. The NEC requires ground fault circuit interrupter protection for swimming pool pump motors due to the high risk of electrical shock in and around swimming pools. Water is an excellent conductor of electricity, and any electrical fault can pose a significant hazard to swimmers and others in the vicinity. Ground fault circuit interrupters provide a critical layer of protection by quickly detecting and interrupting ground faults, preventing potentially fatal electrical shocks. There are no exceptions to the ground fault circuit interrupter protection requirement for swimming pool pump motors based on the wiring method. Whether the pump motor is connected via a cord and plug or is hardwired, it must have ground fault circuit interrupter protection. This ensures that all swimming pool pump motors, regardless of their installation type, are protected against ground faults. Ground fault circuit interrupter protection can be provided in several ways for swimming pool pump motors. Firstly, a ground fault circuit interrupter circuit breaker can be installed in the electrical panel to protect the entire circuit that supplies power to the pump motor. Secondly, a ground fault circuit interrupter receptacle can be installed at the location where the pump motor is plugged in. Thirdly, a ground fault circuit interrupter protection can be provided within the pump motor itself, as some motors come with built-in ground fault circuit interrupter protection. When selecting ground fault circuit interrupter protection for a swimming pool pump motor, it is essential to consider several factors. The ground fault circuit interrupter must be rated appropriately for the voltage and current requirements of the pump motor. The ground fault circuit interrupter should be listed by a recognized testing laboratory, such as Underwriters Laboratories, to ensure it meets safety standards. The ground fault circuit interrupter should be installed in a location that is readily accessible for testing and maintenance. The ground fault circuit interrupter should be tested monthly to ensure it is functioning correctly. Proper installation and maintenance are essential for ensuring the effectiveness of ground fault circuit interrupter protection. The ground fault circuit interrupter should be installed by a qualified electrician in accordance with the NEC and local electrical codes. The ground fault circuit interrupter should be tested monthly by pressing the test button and verifying that it trips. If the ground fault circuit interrupter fails to trip during testing, it should be replaced immediately. Regular inspection of the wiring and connections associated with the pump motor and ground fault circuit interrupter is also important to identify and address any potential issues. Ignoring ground fault circuit interrupter requirements for swimming pool pump motors can lead to serious consequences, including electrical shock, injury, and even death. Electrical code violations can result in fines and legal penalties. Insurance companies may deny coverage for incidents involving electrical shock if ground fault circuit interrupter protection is not properly installed and maintained. Ensuring compliance with ground fault circuit interrupter requirements is crucial for protecting the safety of individuals using and maintaining swimming pools. In addition to ground fault circuit interrupter protection, there are several other safety measures that should be taken to prevent electrical shock hazards around swimming pools. Bonding all metal parts of the pool structure and equipment together to create an equipotential plane. Using non-conductive materials for pool decks and walkways. Installing warning signs to alert people to the potential electrical hazards. Educating pool users about electrical safety. Avoiding the use of electrical appliances near the pool. Ground fault circuit interrupters are not a substitute for other safety measures. They are a supplemental layer of protection that should be used in conjunction with other safety practices to minimize the risk of electrical shock. Always consult with a qualified electrician for any electrical work related to swimming pools and to ensure compliance with all applicable codes and regulations. Understanding the specific requirements of NEC Section 680.21 B1 is crucial for ensuring compliance and safety. This section provides detailed guidelines for ground fault circuit interrupter protection of swimming pool pump motors, including the types of equipment that require protection, the methods of providing protection, and the testing and maintenance requirements. Familiarizing oneself with this section of the NEC is essential for anyone involved in the installation, maintenance, or inspection of swimming pool electrical systems. In summary, ground fault circuit interrupter protection is a critical safety requirement for all swimming pool pump motors, regardless of whether they are cord and plug connected or hardwired. Complying with NEC Section 680.21 B1 and implementing other safety measures can significantly reduce the risk of electrical shock hazards and ensure the safety of individuals using and maintaining swimming pools.